I've lived in this house for just about 4 years now, and ever since I moved in, the doorbell does not work. And I was wondering, is it something I can fix myself? Or even more importantly, is it something that I can make better? Wouldn't it be great if instead of just having my doorbell ring inside my house, I know that even when I'm away from home, if someone presses the doorbell, I can log and get notification that someone was there? Well, that's what we're going to look at today. So most likely in your house, if you just have a single doorbell at your front door and not one at your rear, there's going to be 3 locations that you're going to look at for your doorbell. 1, obviously at the front door where the actual button is. 2 is somewhere inside your house. For me, it's in the garage. Is you have a transformer like this. And then from there, it goes to the actual chimes inside the house. Now, my problem, I'm pretty sure I've narrowed down to this transformer. I've taken it off the wall, and inside the wall, I'm getting the 120 volts from the electricity coming out of the wall, but testing it here where I should be getting 16 volts, I'm not getting any readings, so I'm pretty sure it's a bad transformer. Now, to replace the transformer, it cost me about $15 for a new transformer. Just relook at the wires and screw it in the wall, and I should be good to go. But can I make it better? How much will it cost me? Right now with a Raspberry Pi I could definitely make it better, and that's what we're going to do today. But it's going to cost a little bit more. Obviously a Raspberry Pi costs more than $15 at the time of filming this. But as computers get cheaper, as with the new $9 computer that I keep mentioning because I'm so excited at this point about it, and hopefully it's not a disappointment when it comes out, the chip, I could do this for, well, $9. So I could actually make a better system for less money than the transformer cost me. Because right now, what I've done is I've taken this out of the equation. I don't need the electricity unless I want to power my Raspberry Pi or chip off the electricity, in which case I could do that as well. But all I'm doing is I'm bypassing this. There's 2 sets of wires coming into this. One from the doorbell and one going to the chimes inside. Well, I disconnected it all together and just twisted the wires together from the doorbell to the chimes, completely excluding this transformer. So I use my multimeter to check that the connection is good from here to the chimes and here to the door, and they are good. And I just picked, for me, there's 6 wires I think coming out of each of these, and I just picked 2. I picked the solid blue and the striped blue, just randomly picked those, and I ran that, and that runs to the chimes inside. Now I could hook the Raspberry Pi up right out here. But a few reasons I chose not to do that, because currently the USB Wi-Fi dongle I have on it is not very good, and it doesn't get a very good signal, actually almost no signal out here in the garage, where the actual chimes are right next to my router. And 2, I live in Florida, it's very humid in the air here, not good for electronics. I'd much rather have my Raspberry Pi or whatever computer I'm using located in a air-conditioned part of the house. And the chimes are right in my hallway. Now, from there, just like in our previous tutorial where we had a button press, this is exactly the same thing at this point. Because the button press of the doorbell at the front door is exactly the same as the button press we were doing on the breadboard yesterday. We just have a long wire going through the house to it. So I've hooked up to GPIO pin 23, just as we did last week, and to the 3-volt pin number 1 on the Raspberry Pi. At this point, I can use the same code we used last week to detect whether the button's being pressed or not, but we want to do more than that. So I have created a simple little set of scripts and put them up on GitHub. There should be a link in the description to this video. And today we're going to have a quick look at that code, which can definitely be improved upon. And if I do end up doing this as a permanent thing in my house, I'm definitely going to go a different direction than I did. But the code I wrote does work. I tested it the other day. I had my wife's computer, my phone, and tablet all hooked up, and when I pressed the button, they all rang and logged what time the doorbell was pressed. So let's go ahead and look at that code. Okay, in the link in the description of this video, you should see a link leading to my GitHub account where I have a project called Raspberry Pi Doorbell Notifier. And it's a very simple script, and as I already mentioned, I think that the way I went about this works, and it's not the best option, though. If I was set up this full-time, I would have done more of it on the server side and less on the client side. But it works regardless at this point. but all you have to do is download this project, and there's just a few simple files. Mainly, we have our index file here. We also have an MP3 file. The MP3 file is what will play when the doorbell is pressed. Of course, this is an MP3. If you're using a browser that doesn't have only has open source codecs, you also want to create an OGG file and point it to that instead. But we'll click index here and have a look at the index file. I am using some jQuery in here. Again, jQuery is something you never need to use, but it does make some things simpler, and I do like using it. And what we're saying here is when the document is ready, so once the page is loaded, now add in an audio element. So we're creating an audio element. We're adding it to the div tag down here. And we're loading a MP3 to it, and that's that Bell MP3. Next, we have our main function here I call checker. It's checking the doorbell. Basically, it's creating a time interval called bell check, which is looping 20 times a second. See, and this is why I say it would be more efficient to do stuff on the server. If I actually did more of a server-side script, because right now the server-side script is just a shell script that outputs, it cats out the button press, so it's either going to be 0 or 1. It'd be better if we had the server-side script constantly running and logging stuff, and then every second or so the checker checks for updates, or whatever client side you're using checks for updates. It'd be less of a chance of something getting missed if a button is pressed rapidly, without being held down too long. But this works. Again, for now I had 4 devices hooked up to it at once and it was working. But it's looping, and what is it doing? Well, it's looping 20 times a second, and it's checking our server-side script, which we'll look at in a moment, but again, it's just catting out the GPIO pin, which is going to be a value of 0 or 1. I do have it catting out, or console logging the data, which again will be a 0 or 1 to the JavaScript console of your browser. That was just for error checking. That line can be commented out at this point. And we're saying, okay, if the pin is 1, if the button is being pressed, this is just like our bash script the last week, our shell script. If it's 0, do something, or 1, do something. Here we're saying if it's pressed, well then we're going to play our bell sound that we loaded up here. We're also going to append a message to this div tag here. It's just a log of saying the doorbell rang at, and it's a timestamp, and then creating a new line. Next, we're going to stop this loop. It's checking 20 times a second. Well, the button was just pressed. We don't want it continuing checking, so we're saying stop it, and in 3 seconds start checking again, because our audio file is 3 seconds. So that's it. It's very simple and works. But again, I think that really this sort of stuff would have been better to have the server-side script doing, and this one just checking the log rather than creating its own log. But again, always time to improve it in the future. This is functional. The only thing in our JS folder is a copy of jQuery, and then we have our CGI script, which is just a shell script. It's saying that to use the SH environment to run this, and then I'm not running Apache or anything. I am just running this as a BusyBox HTTPD, which I've done tutorials on in the past, and a CGI script, a server-side script, can be written in any language you want. C, C++, Python, Perl, whatever. I'm using a shell script, but any of them have to output what type of file it is. This is just telling the client this is a text HTML file, and then an empty line. And after that, you just run it just as a regular shell script, which in this case, we're catting out the value of pin 23, since that's the pin we used, which again will be a 1 or 0. So basically, our web browser is 20 times a second. If your device is fast enough to go that fast, it's checking the value of that. And anytime that the button is being pressed, play the audio file. Only thing to know about this is some mobile browsers won't auto-load. It will load the audio, but won't auto-play the audio. So when you load the page, press play once, listen to the doorbell, play once, and then after that, if the button is pressed, it will play. So that is it. It's a very simple script again, but I should have went a different route when I was writing this and done more on the server side. So now I have a functioning doorbell with a Raspberry Pi. Now, I'm not going to leave this hooked up all the time right now because I have other things I want to do with my Raspberry Pi, but again, I'm very excited with how cheap computers are coming with, again, the chip $9 computer. And I hope, even though I keep mentioning this, I hope again that by the time these videos come out and it's released, that chip doesn't turn out to be a piece of crap and a failure. But it seems like it's a great product for doing stuff like this. Again, keeping the price down. For at least us in the US, right now it's $9 for the board and another $5 for shipping. So $14 altogether, $1 less than the transformer alone would cost for this. And now, do I not only get a bell in my house, but I can access the log or receive notification anywhere. Again, in this script in this video, we looked at a script that did it through a basic HTML interface, but we could have that server-side script send text messages, so my phone doesn't necessarily have to always be logged into that website to access it. I could have, when the button's pressed, it sends me a text message, which may be a few seconds delay if I'm out and about. It doesn't really matter. Doorbell rings, and I'm not home. I just kind of want to know that the doorbell rang, so maybe I could look at, I got a camera up here, I can see who's at the door if I want. Other options, again, as I mentioned, is using sockets, which would give you an instant, the second it's pressed, you're notified. Where what we've done today is constant form gets for through HTTP, which gives us a pretty good, and again, within a second notification if we're checking it. So lots of options on how to do this. The way we looked over today may have not been the absolute best, but it's definitely a functional option and great, fine if you're in your house and you just have your computer logged on. And again, you can use wget to constantly be checking that, although there might be a slight delay and it might miss the button press. So again, going with a server-side script to do most of the work would be a better option, and just have your client-side script check that log for any updates. So again, when computers come out that are a little bit cheaper, such as chip when it's released, I hope to get a few and make things like this permanent in my house, in which case I'll definitely update that script and let you guys know, keep you updated, maybe do an update video. But I hope you enjoyed this, and as always, I hope that you visit my website, filmsbykris.com. That's Chris with a K. There should be a link in the description, as well as a link to the code on GitHub. Also, if you like this video, you like this topic, be sure to like, subscribe, share, and comment. And if you want to become a supporter, go to patreon.com/metalx1000. Every little bit helps me just take the time to make these videos, and also gives you some benefits such as input and bonuses such as downloadable videos and early videos. So I thank you so much for watching. I hope that you have a great day.
Okay, this is an introduction to filmsbykris.com. I'm Chris, that's Chris with the K. That's me right there. My daughter Ember, and my wife Jennifer. We pretty much live in the swamps of Florida. I'm a firefighter by day, as well as by night. We work long hours. But that's not why you're here. You're here about the videos I put up on YouTube. These videos are mainly about computers and programming, which means most of my videos look something like this. And if that's what you're interested in, great. If not, that's alright. I do videos on other topics too, such as video editing, special effects, photo editing, 3D design, and music creation. If you are one of my viewers and you enjoy my videos, my Patreon page is a place where you can go to help support my videos. So I ask that you take the time to go to my Patreon page and look at different levels of rewards you can receive for different levels of backing. There should be a link in the description of this video if you are watching it on YouTube. Otherwise, you can visit patreon.com/MetalX1000. And I thank you for your time and your support. Have a great day.